Hi, I am Aditya Ojha.
I'm Anuj.
Hi, I'm Ananya, and this is a video for the Rtes project.
Need
Need
for
for
speed. So in our model, we place the board right on the thigh, and like you can see here the UI. So when you press the start button, you get a prompt of the height of the person. So you can input the height, which is 180 right now, and when you press launch, it starts. Now you can see that the distance traveled was 23.70 meters in 20 seconds, which was a problem statement. So yes.
Hello. So this is our main function. This is the driver function that runs everything. In this driver function, because we have multiple menus that we need to take care of, we have a switch case while with an infinite while loop. The switch case goes on to multiple screens that we have for our UI, which will be explained in the UI section. So for the first screen is splash screen. It is the first screen that you see when you run the program on the board. So it explains what the program is, and it explains the course details and who all have made the project. That's me. Anyway, so here we are just giving a menu, like just a start button for the person to press and just go on to the further options. Then we have config screen view, which is where the program takes the input for the person's height, which could be anywhere between which could be anything in centimeters. Then we have the default height is 178 centimeters, by the way, and we have a lot of UI related things over here where we are changing the text color, back color, and so on and so forth. These are not particularly commented because we have already commented them once. We don't want to repeat that again and again. It clutters the code. Then we have various touch restrictions. For example, if the LED is so and so, the LCD on the board is around 350 height and 240 width, where if you touch above certain pixel length, main screen will open up. So that's how we create buttons on the screen. We are making it interactive because our screen is touchscreen. Then we have the main calculation code, which is the main screen view. Here we are accessing a lot of header files. There's SS stream, there's string, there's the HAL file, and there's the gyro file, obviously. Now I'll explain what the files are. This is for the LCD, for the gyro. This is the writer function that saves the data in the flash memory. This is basically the board's driver file, board's header file, and this is SS stream, again helpful in the writer function. And this is string. This is just something we use for typecasting because our data is in float, and we need to transfer it to char constant char pointer for saving it in flash. I'll explain this later. Second important thing we have is the zero noise rate, and this is the address where the data is stored, so we can just access that later. Anyway, these are the pins responsible for our board to perform SPI. This can be referred and confirmed in the data sheet. Following that, the output is on PC1, register PC1. The next thing we have is a lot of calculations. First, there's a lot of UI design over here. This is just our output is in a graph form. We'll show that in the UI section, but our output is in a graph form, so we need that to be visually appealing. This is why we have this amount of code just going into UI. Apart from that, this is where we calculate the speed, distance traveled, and finally show the graph view. Now, the thing is, we calculate our distance by taking displacement in the x-axis, and that's how it's the same as throwing a projectile, calculating the height and seeing how far the projectile went. It's basic kinematics, and we are using that to calculate our calculate our average speed, angular velocity as well. Anyway, we have this function, main screen view. All the initials are set to 0. The counter is also set to 0, as we can say second counter is set to 1, as we can see seconds are counted to 1. Then we start the program. It shows the time, speed, distance, all in the graph view, and we create an option to end the program earlier than 20 seconds, since 20 seconds is our limit. Then we have a lot of code that's just this is basically the ADC section, or more like pre-processing section of the code. We are trying to correct the offset errors, and we are trying to add convert raw data into usable information basically. So this is what's happening with the 3 gyro inputs, raw inputs. But we are not using y and z because we don't care about those axes. We only need forward velocity. So x is the only one we are targeting right now. There's average velocity calculation and some touchscreen stuff. Then we have the result view, which is the final page that is shown after 20 seconds, where we have congratulations done and distance traveled and a summary of everything. So this is the code for that, and the next thing we have is the writer function. So particularly writing the stored values to flash drive was a bit tricky, but what we did was we created a header file writer.h, declared our function over here with 3 parameters: flash address, where we store our data, the actual data itself, and the size of the data. So we know exactly how much data we are storing, where we are storing it, and what type of data we are storing. So we have these. Then we create the writer CPP function, which basically opens the flash drive. If I'm to simplify it very easily, it opens the flash drive, stores the data right at the address after performing typecasting, which is done when the function is called, and it moves on to the next word, decrements the data size, and closes the flash again, or locks the flash. Then the writer file, when it is called, it's called in the main screen display. So from lines 127 to line 140 are solely based on storing the storing the instantaneous velocity of the person at that given instant to the flash address. So what we have right now is typecasting our print speed into we have a new variable float val, which takes the value of print speed, then performs typecasting on it so that we can convert it into a character and thereby store it into a text file, which is what's happening in this section. So CSTR is the value that we have, which is basically saying number 2 is an int, number 2 is a char. It's the same thing. Then what we have is we call the function over here, and we store the value into the flash drive, and that's all. There are a few other C++ files like LCD, which is basically get size, and most of the things that are already configured in HAL. So this is the main focus of our code, and that's all.
Hi, so I'll show you the demo of our UI. So as you can see, this is the welcome screen, which shows up when the board is booted up. So as you can see, when I click on the start button, so this is the main screen where you can select the height of the person, and after selecting, you can either increase it. For now I'm going to set it for 179 and just press on the launch button. So as you can see is the dynamic graph, and also you can see the readings, the meter distance traveled, the speed, as well as the timer, which is clocked up to 20 seconds. And when I move this board, so as you can see, it will capture the measurements in the y-axis, the projectile, and through that the distance is calculated. So as you can see, the total distance traveled was 6 meters, which is a dummy reading in 20 seconds. Thank you.